Okay, let's talk about fitting lines to scatter plots. This is a super useful thing to do. Lots of different people, not just statisticians and mathematicians, but all sorts of people who work with data of any type. This is one of the main things that they use in order to be able to predict values. So we'll be talking about finding the middle of the data, the middle of the scatter plot points, and we'll be talking about slope and y-intercept. So first, let's ask ourselves, why do we want to fit a line in the first place? Well, what it does is it allows us to predict values we don't already have in the scatter plots. What do I mean by that? Let's go ahead and look at an example. So here's a scatter plot where we have a whole bunch of data points that show a relationship between x and y. And you can see that those data points are lined up in kind of a linear fashion. And you can see we've also put what we call a fit line there, okay? Now the fit line is meant to represent the kind of linear relationship. You can see some of the points are almost exactly on the line, like this one right here. Many are just off of the line, so there's definitely some variability here. The points don't have to be exactly on the line, but the fit line gives you a general idea of the relationship between x and y. And of course, with a line, we can come up with a linear equation for that. So notice that the fit line is kind of in the middle of the data. That's what we mean. It's kind of shooting right up the middle of the linear pattern there. And that's what you want from a fit line. Now, once you have put a line that looks good, you'll want to find the slope and y-intercept. Why? Well, because then you can put the equation in a functional form of y equals mx plus b, or the slope-intercept form, same thing. Okay, and the reason you'll want to do that is because then it allows you to predict points. So for instance, back over on this graph right here, we don't really have a data point in this area right here, right around, let's say, 15. But if we had an equation, we could put that 15 in for x, and then we could predict what the data point would be there. We could also predict what data points would look like out here for values of x greater than what were shown on the scatter plot. So it's really useful for helping us to predict what's going to happen in the real world. Now let's look a little bit at slope and intercept with another example here. So here we have another set of scatter plot points, and we're trying to fit the line here. And what you'll do when you actually do this is you'll try to fit different lines. There's different technologies that can actually calculate the line for you, but you'll want to practice fitting different lines. So what can we say about these three lines here? Well, one of the things we can say is it looks like the orange line is the best fit. It's right in the middle of the data, which means also that it has both the right slope to match the data points and the right y-intercept. Okay, looks good. Now, what about the purple line? The purple line looks like it has the right slope, the same slope as the orange line, but its y-intercept is too high. So that puts the purple line kind of above too much of the data. More than half of the data is below the purple line, and it's almost above all of the data. So it's not really a good fit line. It needs to be more in the middle. And what about the yellow line? Well, it's also below the most of the data, and the reason it is because its y-intercept is good, but its slope is not great enough. It needs to have a greater slope to be coming up here into the middle of the data. So it's down below most of the data points. So what you'll do is you'll practice with different lines to fit into your data, and that will allow you to predict values.